In this video, we're going to analyze the law of conservation of mass, which is a law that all chemical reactions follow. The law of conservation of mass just says that in a chemical reaction, the mass of the products is going to be equal to the mass of the reactants. You can write it this way: mass of reactants is equal to mass of products. So for example, if you have several reactants and you add their masses together, at the end, you should end up with the same mass. It essentially means you can't create or destroy matter. You just rearrange it and connect it in different ways. So if I bake a cake and I have, like, let's say 3 pounds of ingredients, I have a cake, 3 pounds of ingredients. At the end, I should have roughly 3 pounds of cake. I shouldn't have 10 pounds of cake. I didn't create new matter. As long as I did all the reactions right, everything should be accounted for in the end. So every reaction has to follow that. And that's going to be important when we get into balancing equations, because balanced equations follow the law of conservation of mass. So a simple way to demonstrate this is if you do an experiment, you might have a glow stick. You measure the glow stick before you crack it, because when you crack it, what happens is a chemical reaction happens to make it glow. So the glow stick, you measure the weight of it, the mass of it before you crack it, and you'll see you might get, let's say, 4 grams. Then you crack it afterwards and a reaction happens, you put it back on the balance to weigh the mass, and you'll still have 4 grams. You didn't lose anything, you didn't gain anything, the mass is equal before and after. So we're going to do a few problems where you might have to determine the mass before and after using the law of conservation of mass. So let's take a look at this reaction here. In the following reaction, NaN3 decomposes to form Na plus N2. If 500 grams of NaN3 decomposes to form 323.20 grams of N2, how much Na is produced? Assume everything reacts. Show all your work. So first, I'm going to write out this reaction, this equation. 2NaN3 decomposes to form 2Na plus 3N2. And we're told that we have 500 grams of NaN3. So 500 grams of NaN3. And when it decomposes, it's going to make 323.20 grams of Na. And we're wondering, nope, not Na, sorry, of N2. So 323.20 grams of N2. And we want to know how many grams of Na are made. So you don't really have to do anything with the equation. It's just a way to let you understand what's happening in the reaction. You just really have to worry about the math and understand that because of the LCM, the law of conservation of mass, remember that the 500 grams that we started off with, if everything reacts, at the very end we should still have 500 grams, but of product this time. So 323.20 grams plus your X plus your sodium should be equal to 500 grams. So to find your X, you're just solving for X, right? You're taking away 323 from both sides. So you're going to have X is equal to 500 minus 323.20. And those are all grams, units of grams, so make sure you put your units. Basically, you're just trying to say what must X be so that when I add it to 323.20, that it gives me 500. So we have 500 minus 300 is 200, minus 20 is 180, minus 3 is 177, so 176.8 grams. So this is how much our mass should be for this particular problem, because you just do 500 minus 323.20 to get what the value of X is because of the law of conservation of mass. So I would expect you do some planning, you show me your work, you can explain that this is because of the law of conservation of mass, and you show me your final answer, 176.8 grams of Na would have been produced. So you can try the next problem here, pause the video, try it yourself, and then we'll take it up. So a thin strip of iron with a mass of 15.72 grams, there should be a unit there, is placed in a solution containing 21.12 grams of copper 2 sulfate, and copper begins to form. After a while, the reaction stops because all the copper 2 sulfate has reacted. The leftover iron strip is found to have a mass of 8.33 grams. The mass of copper formed is found to be 8.41 grams. What mass of iron 2 sulfate has been formed in the reaction? There's a lot going on here. The best way to summarize it is basically to write out a reaction for it. So it says you have iron, and you place it in a solution of copper 2 sulfate. So that's CuSO4. And when it reacts, it's going to make, it says copper. And then it also says that we want to know the mass of iron 2 sulfate. So there's some FeSO4 made here. So we're told that we had 15.72 grams of iron. And for copper 2 sulfate, we had 21.12 grams of copper 2 sulfate. And it says that the mass of copper that formed was 8.41 grams. And we want to know how much iron sulfate was formed. Now the thing is you have to be careful of here is that you do have some leftover iron. So at the end, you do have leftover iron. So it says 8.33 grams left over. Okay? So that's the only tricky part. It's not just reactant and product. There's a reactant, product, and then leftover reactant at the end. So everything's the same, except you have to take into account that leftover. So our mass at the beginning is the 15.72 plus 21.12. So we have 36.72, 36.82, 36.84 grams, 36.84 grams, right, that's just them added together, is going to be equal to the 8.41 plus x plus 8.33. I'm going to add 8.41 and 8.33 together, so it's 16.74, so 16.74 grams plus x. Okay, so you're still just looking for x, because this, and this should be equal to the total here, assuming I did all my math right in my head here. So to find x, we're simply going to do 36.84 grams minus 16.74 grams, right? Because you're isolating for x, you're just removing 16.74 from both sides, or you might say sending 16.74 to the opposite side of the equation, which makes it negative. So that brings us to 20.10 grams or 20.1 grams. You don't have to round right now. If you do round, you do have to round, I'd tell you to how many decimal places. So this is grams of FeSO4. So that one is a bit more involved because there was some leftovers. You don't always have questions like that, but to be honest, in chemical reactions, you often do have a leftover because you use too much of one, and so you have to take into account the leftover, and that's what would account for the mass being the same before and after. We'll do one more problem. This one is a good challenging one. You can try out the answer keys here for that one. You won't be expected to necessarily do this one, but I always recommend you try it for enrichment. But let's try this one here. So pause the video, try this out, and then we'll come back to, and then we'll take it up. So at this point, we're just taking up the problem that you just did. So reaction between sodium hydroxide and hydrogen chloride gas produces sodium chloride and water. So let's just write out an equation. NaOH plus hydrogen chloride. And you could write it with words too. It doesn't have to be formulas. Notice I'm just practicing my formula writing here. Produces sodium chloride and some water. And it says that you have 22.85 grams of NaOH and then 20.82 grams of the hydrogen chloride. And it makes 10.29 grams of water. And we want to find out what mass of sodium chloride formed. So we know that because of the LCM, law of conservation of mass, that the reactants and products need to be the same. Okay, so mass-wise, so the total mass of the reactants is 22 plus 20. That's 42.8. Then plus another 0.8 would make it 43.16. So then we'd have 0.21, 0.23. So 43.23 grams. Did I do my mental math right? Let's double check. I was doing that pretty quickly. Let's get our calculator out, because sometimes we get nervous when we do math in our head. We don't have to, but you can always double check your work. I always tell students that during a test, if you need your calculator to try some decimal math, you're allowed to do that. You should be pretty quick with math. Let's see if I made a mistake here. Whoops, yeah, I did. 43.67. Always double check your work. So, let's see. We did 22.85 plus our 20.82, 43.67. And that should be equal to x plus 10.29 grams. And so what we're going to do now is we're going to solve for x, because that's what we're trying to find here, the mass of sodium chloride. So we're just going to do that x is equal to our 43.67 grams minus 10.29 grams. And so we'll get 33.38 grams of NaCl. So we just did 43 minus 10 gives you 33. We had 33.67 minus 0.2, that's 0.47, and then we had one left over, so 0.48. So let's double check our math. So again, I try to do mental math as much as I can, and sometimes if you double check it, you can do that. So 43.67 minus 10.29, and we get 33.38 grams. So the reason I did this is to show you that practicing your mental math is important. You're allowed to have your calculator with you, but try to become fairly quick at doing some mental math, so it speeds the process up a bit. You're not always punching numbers in, right? You shouldn't be punching in 2 times 8 anymore. You should know that's 16. But again, double checking is important as well, so you have your trusty tool with you as needed. So in this lesson, we saw the law of conservation of mass. We did some math problems with it, and the reason we're doing that is because all chemical reactions follow this, and to represent that, we can no longer use skeleton equations. We're going to have to use balanced equations with these big numbers in the front called coefficients, and we'll see that in the next video lesson.